Hello, welcome to Vedil Vagparai. In this video, we are going to see about aldols and ketones. This particular video is based on aldol condensation and nucleophilic addition reactions. And also there is a little bit of stereochemistry in this particular reaction. And this particular question is taken from IIT JEE 2023 question paper. Let's see the question first. Consider the following reaction: propanol plus methanol, and then a set of reagents are given and the product is given. And they have given four options. In these four options, two of the options say that the product is optically active, two say the product is a racemic mixture, and further to that, they also say the product can add a mole of bromine, the product is a neutral molecule, and this option says the product is reacting with sodium bicarbonate and a gas is evolved. And the final one is saying the product is an optically active alcohol and is neutral. So we'll have to find out which of these choices are correct. Before we find out which of these choices are correct, we must first see what are these reactions and how are these reactants reacting with these reagents. And then what is the product that is formed. And after the reaction, we can finally make out what is the solution for this particular reaction. So let us see a detailed structural representation. So you know propanol is represented like this and methanol is represented like this. And this first set of reagents is actually aldol condensation because dilute sodium hydroxide is used. And you see here that between the two aldehydes that are there, the aldehyde propanol has alpha carbon and this alpha carbon has alpha hydrogen. So this aldehyde is having an alpha hydrogen, and so this can undergo aldol condensation reaction, though the other aldehyde does not have alpha hydrogen. And not only that, this is having a mixture of aldehydes, so this is mixed aldol condensation. But because one of the aldehyde only has alpha hydrogen, and the other one doesn't, we know pretty well you will get exclusively only one kind of a product with aldol condensation reaction. And then the second set of reaction is nothing but a simple nucleophilic addition reaction to an aldehyde or a ketone followed by hydrolysis. So we will first see the aldol condensation mechanism and then we will move over to nucleophilic addition reactions. So let us see aldol condensation reactions. This aldol condensation reaction happens in the presence of a dilute base and it is a base catalyzed reaction. That is, the base is regenerated at the end of the reaction. So as I told you, in this particular molecule, the alpha carbon has two alpha hydrogens. So this is a classical example of aldol addition reaction. So aldol condensation reaction is actually a combination of two sets of reaction. First, an addition reaction followed by condensation. So in the first step, as we talked about in case of nucleophilic addition reaction, the nucleophile is formed. That is we see the mechanism here. The base abstracts the alpha proton, the proton from the alpha carbon. So this proton is removed, and because the base abstracts the proton, we know this particular carbon becomes a carbon ion, becomes a carbon ion, and as a result, what we get here is a enolate, enol. Okay, so because there is a negative charge, it's called as an enolate. So if this particular molecule can exist in enolate form or in the keto form, then the double bond is on oxygen and the negative charge is on carbon atom. So whatever said and done, in this particular case, the reaction is happening at the carbon atom only. Usually there will be a confusion where the reaction happens, whether it is happening at the carbon or at the oxygen, because the negative charge is on the oxygen. But in this particular reaction, in this enolate, the negative charge is rearranged, and then the carbon is the place, or the carbon ion is the one which is reacting with the carbonyl carbon. So this is a typical nucleophilic addition reaction of a nucleophile. So this molecule behaves like a nucleophile and attacks the carbonyl carbon, and then oxygen is polarized. So this product that is formed is neutralized, and then what we get here is aldol. This is aldol because this is having aldehyde and alcohol. The product is called as a aldol. So in this particular molecule, we know that there is the alpha and beta positions. So this is the product that is formed. And now The next step in this particular reaction is, if in this alpha position you see hydrogens are not spelled out. So the second step is the condensation reaction, wherein water is removed from the alpha beta carbons. So alpha carbon cleaves out the hydrogen and the beta carbon cleaves out the OH group. So here we see very clearly the hydrogen from the alpha carbon and the OH from the beta carbon are removed. So because they are removed, so you will get a unsaturated aldehyde. So very easy. So this group is shifting, the double bond shifts here, and that is how we get it here. So this is a more detailed way of showing the mechanism. But in simple terms, what I say is the protons of the alpha carbon and the OH and the beta carbon is removed, and then a double bond is formed between alpha and beta carbon. So this is the reason why this particular product is called as alpha beta unsaturated aldehyde. So in this particular molecule, reaction, we also see that the OH minus is regenerated. So this is a typical aldol condensation reaction, and the same is noticed can be written for our present reagents also. So the next set of reaction is the reaction of formation of cyanohydride is a reaction of sodium cyanide with an aldehyde or a ketone. So as I told you, it's a typical nucleophilic addition reaction wherein Cn minus is a nucleophile. Usually we will see HCN, but then when we see sodium cyanide is more ionic, so preferable use of salt of cyanide is used. So Cn minus attacks the carbon, carbonyl carbon, and then the O shifts. So this is how we get the cyanohydrin. So this is the cyanohydrin that is formed. So the first step is the nucleophilic attack. The second step is deprotonation. So this is an addition product. This is a typical reaction of all the aldehydes and ketones. And aldol also, what we see is also a typical addition reaction followed by condensation. So here again, the second step is this cyanohydrin, when it is treated with acid, then it can, convert itself into carboxylic acid. So when treated with HCl, H3O plus ions, the Cn will convert to acid. So this is a very important reaction. So if it is a reaction wherein Cn reacts with an acid, usually sometimes it will convert to an amide, and the amide will become a carboxylic acid. And so under prolonged and severe conditions, we see it will form a carboxylic acid. So now there are two things that you have to keep in mind. Cn will first form an amide, and the amide will become an acid. So, but finally it will form only a acid. So this is actually an acid having an OH group on its alpha carbon. So if there is a condition, then this OH can be removed and it can become a unsaturated acid also. So, but now let us go back to the question that is given to us. So let us see the question now. So in this particular question, what we have seen here is the first is the aldol condensation. So propanol, we have written it in its structural form, and methanol too. And this is the final product, which is the final condensation product. And the shortcut to learning this particular reaction is very easy, because it is just a reaction of the formaldehyde. Let me put it, the formaldehyde here, and then the propanols. This is the alpha carbon. The reaction is happening at the alpha carbon only, and so I will put the structure in such a way wherein you can understand the reaction is happening only at the alpha carbon. So whenever you are looking at an aldol condensation, you can write the structures in this way, so that you know this is the alpha carbon and then the other group that is interacting, and we see water is removed, and the water that is removed leads to the formation of a product, which is this, that is H2C double bond C CH3 CHO. Very simple. So this is what we have written here. So aldol condensation leads to the formation of alpha beta unsaturated aldehyde. And the second step is the nucleophilic addition reaction. In this nucleophilic addition reaction, the reaction is going to happen at the carbonyl oxygen. So when we see the carbonyl oxygen, we know Cn minus is the reacting species or the nucleophile. So the nucleophile will attack the carbon and then oxygen will be polarized, and that is how we see a simple nitrile reaction is happening in this particular case. And this is actually a cyanohydrin, and this cyanohydrin on hydrolysis will first form an amide and then it will lead to the formation of a carboxylic acid. And in this particular case, we have written the equation wherein the Cn is converted, nitrile is converted to carboxylic acid on treatment with on hydrolysis with in the acid medium. Why? Because the molecular formula that is presented in the question shows 3 oxygen atoms which can fit only the formation of the carboxylic acid. Because if it was an amide, there will be only 2 oxygen atoms and there must be nitrogen in this molecular formula. But then this molecular formula fits this structure, and so this is the product. So now let us observe the statements. So in this case, there are 4 options that are given, and the first option says the molecule is optically active and adds 1 mole of bromine. The second says it is a racemic mixture and is neutral. The third one says it is a racemic mixture and gives a gas with saturated sodium bicarbonate. And the fourth one is optically active alcohol and is neutral. So now let us see the nature, because we know that what we have found written here is an acid, and the acid is the one which will react with the saturated solution of sodium bicarbonate to form carbon dioxide and the salt of the acid. So option 3 is something which is suitable in this particular case. But then we cannot rule out the other options also. Say, for example, the first option adds 1 mole of bromine. So we know that there is an unsaturation here, and so 1 mole of bromine addition reaction is possible. A dibromo product can be formed here because it is an unsaturated molecule. And then the next is neutral. And the second and fourth can be ruled out because they are spelling out that the product is a neutral molecule. In this case, it is not a neutral molecule, it's an acidic molecule. And so these two conditions cannot be considered. It is to confuse because nitrile can form an amide. If it was an amide, then this product would be a neutral product. So we know that 2 and 4 are absolutely ruled out. Now the confusion is whether the option is 1 or whether the option is 3, because both the second part are true. Bromination is also possible. Reaction with bicarbonate is also possible. So the only difference is the stereochemistry of the product that is formed. So for that, first look at the carbonyl carbon. So when you see the carbonyl carbon, we know that the carbonyl carbon is a sp2 hybridized carbon, and it is having a trigonal planar geometry. It is a trigonal planar geometry. So if it is a trigonal planar geometry, the 3 atoms are on the plane. So the incoming group can attack from either above or below the plane because of its sp through hybridization. So if there is a starting material it is prochiral, like say in this particular case, this carbonyl group, when it is becoming a nitrile, has 4 different groups attached to it. That is, the carbon which is bearing the carbonyl group has 4 different groups attached to it. And so it's a chiral carbon. So this chiral carbon, we would want to know, is it an enantiomerically pure molecule or is it a racemic mixture? Because there is no particular attack, because it is an sp2 carbon and the possibility of attack is from both above and below, this particular molecule will result in the formation of a racemic mixture. That is, both the enantiomers will be formed in equal amounts. So that is the reason why option 3 is correct and option 1 is not correct or incorrect, because it will not form an optically active compound, because it will form equal mixture of enantiomers and racemic mixtures. So in total, in this particular reaction, we have seen 2 sets of reactions of aldehydes, and then we have also seen the stereochemistry of the products formed in a nucleophilic addition reaction. So for any nucleophilic addition reaction, you have to keep in mind if the product is an yeah, it is having an optical active center or a stereo center, then the product will be a racemic mixture because of the ability of the group nucleophile to attack from both the sides of the carbonyl carbon. I hope you understood. Thank you. Have a nice day.